Hello, hope you guys are all having a wonderful day or night, depending on what time you watch this video. Just so you know, today's notes are significantly shorter than yesterday's notes, so I will try to keep them under about 10 minutes at the most. All right, let's get started. So because sinusoidal functions are periodic, we can actually write multiple equations to represent one equation on my graph. So that's what we're going to do today. So if you look at the first equation we have going on here, if you look at your worksheet, you do not actually have the graph, but you have the equation. So I'm going to write the equation where you guys kind of sketch the graph on your page. So just hit pause, sketch the graph, and hit resume when you guys have that taken care of. Sorry about that. We did not mean to leave it out. All right, welcome back. So the equation we have graphed here is m of theta equals -6 sine 4 theta plus 6. So some of these things won't change. So no matter whether it's sine or cosine, my amplitude is going to be 6, my b value is going to be 4, and my vertical shift is going to be y equals 6. So regardless of where I am looking, that information is going to be the same. So now, if I consider writing this as a cosine function, I'm going to start by writing this as a cosine function right here. So I'm going to look at the period of this graph, and this is the end of one full cycle right here. So if you look, you start at the midline, you went down to the bottom, up to the middle, maximum, and back to the middle. So this is one full cycle of my sine function. So if I take one full cycle, so if I take my period of pi over 2, and I take pi over 2 and I divide that into 4 equal parts, pi over 2 in 4 equal parts means each quarter of that graph is going to equal pi over 8. So to keep the rest of this super simple, I am literally going to come and label my whole entire horizontal axis each quarter. So here I have pi over 8. This is 2 pi over 8. My maximum is 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8. Underneath my maximum, I have 7 pi over 8, and then 8 pi over 8 is pi. I'm going to use these values as my phase shifts, as my left and right horizontal shifts. So in algebra, we call them horizontal shifts because we are taking the entire graph, moving it X number to the left or to the right, and we're going from there. However, because these are periodic and we can do multiple different equations, we refer to them as phase shifts. So cosine. So I'm just going to continue to call this the function m of theta. So I know when I look at m of theta, if I start down here at this value right here, I'm starting at my minimum, so it's going to be negative amplitude. And this is a cosine function now because I'm starting at my minimum. I tend to put a square bracket when there's a phase shift, and this is your b value. So up until this point, nothing about this function has changed. This is where we're going to add the phase shift in. I went to the right pi over 8, so I'm going to do theta minus pi over 8, close my parentheses, close my bracket, and then I'm going to add my vertical shift to the end. And that's all there is to it. So basically everything stays the same except for the little phase shift in the middle. So take a minute. I want you to think about this value right up here, and I want you to write a cosine function that starts at that maximum value. So hit pause and rejoin us when you are finished. All right, welcome back. So if you think about what your function should look like, if you start at the max, our amplitude is still 6 because we're starting at the maximum, it's cosine. My b value is still 4. And I went to the right 3 pi over 8, so theta minus 3 pi over 8. And my vertical shift is still 6. Writing equations of the sine will look exactly the same, except this time we're starting on the midline. So if I start at this point right here, I'm going to take the function, and I'm still on m of theta. I still have an amplitude of 6, and because I'm increasing from the midline, that will be positive. So I have 6 sine I'm working with the phase shift, so I just like square brackets when I do phase shifts because it kind of keeps it separate. My b value is still 4. However, if you look directly under this value, I shifted to the right pi over 4, so this will be theta minus pi over 4, and then I still have a vertical shift of 6. All right, and last but not least, let's write another sine function. We're going to start at this value right here, so you take a minute, write that on your own, and come back and we will check it. Welcome back. We have another function m of theta. This time I am still have an amplitude of 6, but because this function is decreasing, which is a reflection of the parent function, I'm going to have a negative. Still a sine function, still has a b value of 4, but this time my phase shift is right here at pi over 2, so I have theta minus pi over 2 and plus 6. All right, let's just try one more graph to make sure that we have the hang of things, and we will be done for today. All right, difference here. I don't have an equation, so I'm going to find the critical values on this graph. So if I look at this graph, I have a midline here. So my midline is there at 3. I have a maximum at 6. So this distance here is 3, which means my amplitude is 3. So basically my amplitude is 3. My vertical shift is up 3. And if I think about my b value, it's pretty easy to think about my period. So if I think of one full cycle on this graph, if I start here and think about pieces, there's piece 1, piece 2, piece 3, and piece 4. So there's my 5 critical points. So right now, my period is 12 units long. So it took me 12 units to do one full cycle, which means my b value is going to be 2 pi over 12 or pi over 6. And yes, I know that's a little bit weird to have your b value have the pi in it, but remember, pi over 6, you could put that in the calculator and get a number. It's just the number of cycles. How frequently does this occur between 0 and 2 pi? All right, so if I want to start by writing a cosine function, I'm going to start down here at the bottom. So I'm going to start with this point right here. And if I do that, I'm going to name my function. I think I'll just name it f of theta because I can. And my amplitude is 3. I'm starting at my minimum, so that's going to be negative. Then negative, this is going to be cosine because I'm starting at the minimum. I do have a phase shift. My frequency or my b value is pi over 6. I'm starting at 3, so this will be theta minus 3. And then I will add my vertical shift. All right, I'm going to switch over and do a sine function. So I'm going to do this sine function right here that's starting at 6. So again, I'm going to name my function f of theta. It's going to look almost identical to the cosine function. So I have an amplitude of 3. However, I'm doing a sine function. B value is pi over 6. I shifted to the right 6. And yes, if your graph shifts to the left, you can go to the left. And then my vertical shift right here. So take a minute, hit pause, and do one more cosine and one more sine function, and we will be done for today. All right, welcome back. We're going to start here at this maximum value. So because that's the maximum, it's going to be a cosine function. Amplitude 3, cosine, my b value is pi over 6. I shifted to the right 9, so this will be theta minus 9, and then I'm going to add my vertical shift. Last but not least, I'm going to start right here at a phase shift of 12, and I have f of theta. Still have an amplitude of 3, however, this time my function is decreasing at that point, so I'm going to be going down, so it's a negative sign, a reflection of my parent function. Still have a b value of pi over 6. And I went to the right 12 to do this and make that happen, and I still have to add my vertical shift. So if you think about it, I want you to ponder tonight, how many different ways could we write an equation for this graph? And that is where we will pick up when you come to class tomorrow. Have a wonderful evening.